Okay, everybody is doing 1B now. So this one, you got one sphere is minus 10 and the other is minus 6. So what happened is that you write down the intro first. And your intro is when a wire is connected from A to B. Okay, spheres A to B. So you you relate it back to the situation. Then after that, you talk about E, electron movement. Electron move from A to B. Okay, you can actually even say how many units? Minus 2 units of electrons or negative charges move from A to B. Right? Then after that, give the reason because B is at a higher potential. Right? A to B, right? Move from A, which is a lower potential. Don't just say A to B, say there, lower, which is lower, A. Then B, higher potential, yes. Right? And that's not all. As a result, the overall effect is that A will have minus 8 units and B will have minus 8 units as well. Right? And they are both considered to be now at the same
negative charge. Negative charge, or can we just say charge?
Same potential. Same negative potential. Yes. Okay. So not very difficult, So for question 2, you read the question. After you read the question, you see, they say a thick metallic can. What's the implication of thick metallic can? So big deal. What does metallic can imply to you? Metallic can, metal.
Mobile electrons.
Mobile electrons. That means electrons can move freely on the can. Right? So they can move about very freely. Okay, inside, outside, whatever. And then on the wooden table, what's the implication? Earth. That means if let's say the can is charged, it's not going to get discharged. Alright, so that's the implication of these two things. Okay, so you identify that which process? Contact? No. Friction? No. Induction? Yes. Okay, then firstly, part A, typical question. Ask you draw first and then explain why. Okay, so draw your charges that will appear on the inside and the outside. So the inside, negative. Yes. So draw negative. Again, draw properly. You're going to draw, let's say, 9 of them on the inside. Up to you how many you want to draw. Make sure the outside, how many?
9.
How many positive outside? 9. Draw on the surface like that. Okay? On the surface. Because these are all at the external surface of the can. It's not inside, on the surface. So as I draw like that. Okay, so that's how they appear, right? Okay. When the positive charge sphere is lowered into the can, electrostatic induction takes place. Okay, so that's my intro statement. Then after that, go with the E and the R and then the O. Okay?
For practice.
Okay, I forgot to explain that. Okay, now for those of you watching the video, for part A, you give the intro. What happens when the negative charge sphere is lowered into the can? Electrostatic induction takes place. Okay, then you talk about electrons, how they move. They move to the inside of the can, right? From the outside, they move to the inside. So as a result, what happened? The outside become positively charged, the inside become negatively charged. Okay, so when you explain, you follow the ERO way, you won't leave out anything. You become very systematic when you answer, alright? Okay, so when the outside is Earth, so my intro statement, The outside of the can is earth. First, E. Systematic answering. E. Electrons will move from
Earth to the outside.
Earth to the outside. The can. R for reason. Because number 1 or number 2?
Number 2.
Number 2, because the outside of the can is at a
Higher potential.
Okay. Then after that, O.
That will be
Neutrally charged. Careful with your words. As a result, outside will be
outside will be
neutral, while inside remains yes, negatively charged. Okay, so you can see slowly as you do this, okay, you will find it's not that difficult. Just think carefully, follow a format, you can work it out, right?